Alright, good afternoon everybody. I had a request for a limiting reactant problem to go along with the worksheet that I gave you all in class. And I wanted to go through a couple of examples and see if I could explain while going through the examples exactly how it's going to work. Now, when we're dealing with, we're actually looking, I'm going to use a couple of examples on the worksheet. So we're going to use number 1 and number 2. We're going to do all parts of it. Now, looking at number 1, it actually starts you off with an equation. It says that it's going to be limiting in excess, and the equation is going to be I2O5 plus 5CO, carbon monoxide, yield 5 carbon dioxide and 1 iodine. I'm given 80 grams of iodine, 5 oxide, and 28 grams of carbon monoxide, and asked to figure out how much of the I2 is produced. We're going to go about this in the same way that we've done our regular stoichiometry. I'm going to set up our table, and we're actually going to, again, go through step by step. So start off writing my given. 80 grams I2O5 is where I'll start. And I need to convert this into moles of I2O5. So how do I do that? How many grams are in 1 mole of I2O5? After using my periodic table, putting some things together, I come out with 1 mole of I2O5 gives me 333.8 grams. Now, this gives me moles of I2O5. I need to end up in the end in moles of I2. So this is where my mole ratio comes in. And remember, moles you want divided by moles you have. So I have, at the moment, I2O5, so it goes to the bottom. And I2 is what I want, so I'll write it up top. Now, from here, I will be switched into moles of I2. So now I need to go from moles of I2 into grams of I2. And I'm going to do that by just multiplying it by the molar mass, after again figuring how many grams are in 1 mole of I2. Once I've done this, all I have to do is multiply what's on top, divide by the bottom, and I'm going to come out with an answer of approximately 60.83. Now, I enjoy limiting in excess problems because half of my work for my next problem is actually already done. What do you mean? Well, let's take a look at it. I'm going to start off making my table just like I normally would. 28 grams of carbon monoxide. Now, I need to fill in the information for carbon monoxide. So, 1 mole, 28.01 grams, again, my molar mass. Now I'm going to come to my mole ratio, where I go from moles of carbon monoxide to moles of I2. 1 mole to 5 of carbon monoxide. And now I'm looking at the same information that I just had, if you notice, right here. The same info, that I put right here, I'm going to go ahead and utilize again. So, with that being the case, I'm going to solve. Once I put my 253.8 over 1 mole, I'm going to go ahead and solve and get 50.74 grams. Now, to figure out which one is my limiting reactant, I want to look and see which of my calculations gave me the least number of grams produced. In the case of what I'm looking at, I see that my calculations with carbon monoxide actually gave me the least amount. I have 50.74 that are actually produced. Because of this, that lets me know that carbon monoxide is my limiting reactant. Now, all it means is, when we look at the limiting reactant, this is the one that we're going to run out of first. So, when the reaction is going on, everything seems good, the reaction suddenly stops. It means that one of the reactants is no longer there. We used all of it and there's none of it left. We're actually going to use up all of the carbon monoxide before we would use up the I2O5. And this is what determines what our limiting reactant is. Now, if you look at your paper, you'll notice that it keeps going on a little bit, and it asks you to do actually a regular mole gram conversion and then asks about percent yield. Let's go ahead and move into that section. Let's see what it looks like. Now, it says that after doing this reaction, 0.160 moles of I2 is actually produced. So what is the mass of iodine produced? All we're going to do is set it up and do our usual table, just like we were doing any other mole calculation, and then we'll move from there to find our grams. So 0.160 times 253.8 will give us a number of 40.61 grams of I2. Now we move on to part 2. What is the percent yield? In your notes, and I'm not sure if you've already picked this up, the formula that we use for percent yield is actually going to be the actual or experimental over the theoretical, which is what you calculated, times 100. In the case of what we're doing here, our actual is going to be our 40.61 grams. That's our actual. That's as if we went into the lab and we actually did this work. Our theoretical is how much we just said that we produced on the previous page with our limiting reactant, which was 50.74. So we just divide 40.61 by 50.74, multiply by 100 and get a final answer of 80.03%. So this would be our percent yield for this reaction if we produced 40.61 grams. Now, this, for the most part, is going to be just like your regular stoichiometry. And so, in this case, you're only doing 2 stoichiometric calculations. 2 of our nice 3-step problems. Now, what if it asks you to go a step beyond and asks you to figure out how much of your excess reactant is left? Because the one that is limiting is also going to be the one that we term as excess. So, let's look at another example. You're given zinc plus sulfur is going to yield zinc sulfide. The question asks, if 25 grams of zinc and 30 grams of sulfur are mixed, which chemical is the limiting reactant? To find the limiting reactant, we have to do our 2 calculations. So, first we're going to go ahead and take the 25 grams, and we're going to follow it through like we normally would. Change it into moles. Next step is our mole ratio, which is a 1-to-1. And then convert it back to grams. This is going to give us an answer of 37.26 grams of zinc. Now that we have the basic idea, we should have the basic idea, I'm actually going to speed through this next part because we should be able to go ahead and follow it. If you'd like, pause this portion and then go ahead and do the calculations and use my video, use my going through it as a little bit of a way to check and see if you've done it correctly. Now, for the second part, I have to start off with my sulfur. So, 30 grams of sulfur, converted as moles, 1-to-1 ratio, and then again multiplying by the 97.47 grams of zinc sulfide, because that is our molar mass for the compound. Once I've multiplied and divided, I'm going to come out for that one with 91.18 grams of zinc sulfide. So the clear winner in this case is what's going to limit my production or stop the reaction is when I run out of zinc. So the next step actually asks me, how much of zinc sulfide will be produced. Since we determined that zinc is our limiting reactant, we looked at the number of grams of zinc sulfide it will produce, which in this case, 37.26 grams. This means that zinc is not only our limiting reactant, but we'll only be able to produce 37.26 grams. Now, the last step says how many grams of the excess reactant will remain after the reaction is over. So this may be a situation of we wanted to continue the reaction, and so you may just add more of the limiting reactant to see how much would be there and how much is present. So what we're going to do is we're going to do another 3-step table, but in the process what we're going to do is we're going to compare our product, which we had here. Oops. No. Okay. It's okay. We'll make it through. So we're going to compare our product. Here we go. Caught up. All right. We'll compare our product, which we said is our limiting product, to our excess reactant, which we found is sulfur. So let's take a look and set it up. We said that we're going to produce 37.26 grams of zinc sulfide, and we need to go ahead and convert that into grams of sulfur. Now, since this is a limiting and excess problem, I'm using information that I've actually already calculated. What I can do is copy the information that I already used in the previous examples here and in the previous one, and I'm just going to rewrite them. So 1 mole zinc sulfide, now I'm going to be dividing by the molar mass, and my mole ratio is still going to be the same. It's still going to be a 1-to-1 ratio. Now, going back to my excess reactant, which we said is sulfur, again, I have all the information that I need. So it's a matter of copying it into place. Once I've put it into place, multiply and divide, I find that in this reaction, to produce 37.26 grams of zinc sulfide, I'm going to use 12.26 grams of sulfur. Now, this isn't the actual answer to the thing. We have one more step to go, and this is actually an easy one. Now, if I've only used 12.26, how do I figure out how much is left? Well, if I started off the overall reaction with 30 grams, and I used 12.26, all I have to do is subtract. So I'm going to subtract 30 minus 12.26, and that gives me 17.74 grams left over of my excess reactant. I hope that this is helpful. Bring any questions you have to class, and we're going to try to answer them and make sure that you understand everything that's going on within the student and prepare you for your test. Have a great evening. I look forward to seeing you in class, and see you tomorrow.